Hello everyone, in this video we'll be solving problem 141 linked list cycle. The problem statement is we are given a head of a linked list. Determine if the linked list has a cycle in it. Return true if there is a cycle, else return false. If you look at example number 1, the node with the value -4 or -4 is connected back to node with value 2, which means it is a cycle. So in this case we are returning true. And also in example number 2, there is a cycle from 2 to 1. So it will be like an infinite loop if we start the iteration until we encounter a null. But in example number 3, there's only one node with value 1 and there are no nodes after it. So in this case, we are returning false. One add-on that is given to us a problem statement is to try to solve this using constant space. That is O of 1. Let's try to solve this problem using the naive approach first and then optimize it to meet this criteria of constant space. Let's switch to whiteboard to talk about the solution. In the naive approach, we can use a data structure to store the values of all the nodes that we come across in the linked list, and if we encounter any duplicate, return true. Let's do a couple of runs to understand how will this work. Let's call the variable values. Starting with the first node in the linked list, its value is 3. Does it exist in the values variable? No. So we'll add it and then move on to the next node. Its value is 2. Does it exist? No. So we'll add one more. Then similarly, we'll add 0. Then -4. The next node after -4 is 2. Does it exist in the values collection? Yes, it exists. So we'll stop the iteration and return true. If the next node after 4 is null, then we'll stop the iteration and return false. This approach solves the problem, but the time complexity will be O of n, where n is the number of elements in the linked list and the space complexity is O of n, as we are using this variable to keep tabs on all the elements in each of the node as we are iterating through the linked list. As the space complexity is O of n, and the problem statement is asking us to solve it in constant space of O of 1, let's think about how we can improve the solution. To solve this problem efficiently, we'll use the two pointers approach, where one pointer will be a fast pointer and the other one will be a slow pointer. The idea is that the fast pointer will be moving at two spaces at a time or at every iteration, while the slow will move at one space at a time. The idea is similar to the relay runs in Olympic Games, where the faster player eventually catches up to the slower player after a couple of laps. Similarly, over here, if there is a cycle in the linked list, the fast pointer will eventually catch up to the slow pointer, and both of the pointers will be pointing at the same node. The iteration will continue until both of the nodes are pointing at the same node, or the fast pointer stumbles upon a node which is null. There are two things that can happen. One is, if there is a cycle, then the iteration will continue to run infinitely. And the other is, if there is a null at any point or there is no cycle, then the fast pointer will eventually come to a halt. Let's do a couple of runs to understand how will this work. Let's start with the fast pointer pointing at node 2 or index 1, while the slow pointer is pointing at index 0, that is node 3. As the values are not equal, we'll continue the iteration. So for the next run, f will be pointing at index 3, that is node -4, while the slow pointer will be pointing at index 1, that is node 2. They are not equal, so we'll continue. For the next iteration, the fast pointer will be pointing at node 0, as we need to move two spaces, while the slow pointer is also pointing at node 0. So its corresponding indexes will be 2 and 2. As both pointers are pointing to the same node, it means that the linked list has a cycle and will return true. The time complexity of this solution is O of n, as we are iterating through all of the nodes, while the space complexity is O of 1, as we are only using these two pointers to point to particular node and incrementing it at different paces. Let me show you how we can implement this using C#. Here is my C# solution. I start by initializing my pointers. Both of them are pointing at the head to begin with. Then I am starting a while loop until fast and fast.next are not null. Then I am setting the new values where the fast is next of next, so moving two spaces, while slow is the next one, so moving one space. If the two are equal, then I'm returning true. If not, we continue the iteration. If at any given point of time we encounter a null, then this condition will not be suffice, so it will exit out of the while loop and return false. This code, when submitted on LeetCode, beats nearly 88% of the submission in terms of runtime complexity, and in terms of memory consumption, beats 100% of the submissions. Thank you for watching this video. I hope you were able to understand this approach and the solution. If you have any questions, feel free to reach out to me. The link to the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.